let's use the rational root theorem to give all of the possible rational roots to this polynomial. So the rational root theorem tells me that the possible rational roots, so that, what does that mean? It's a root, a zero of this function that can be written as a fraction. So we're looking at, maybe 2 makes this 0, or maybe 3/7 makes this 0, right? Something rational. And the pattern is, it's p over q, of course, because it's a rational number. And the p has to divide the last term of the polynomial, the constant, while the q has to divide the front term, the leading coefficient. So in this case, we're looking for rational numbers where p divides 12, right? Plus or minus 12, doesn't matter. And the q needs to divide 4. So let's list out all of the different possibilities. If I think about p has to divide 12. All the divisors of 12 are plus or minus 1, plus or minus 12, plus or minus 2, plus or minus 6, plus or minus 3, plus or minus 4. When I think about q, the denominator, q has to divide 4. So it's either going to be plus or minus 1, plus or minus 4, or plus and minus 2. Now, these are not all of the zeros, right? Because this is a 5th degree polynomial. You're only allowed 5 real zeros. So obviously all of these can't be zeros. These are just the possible zeros. So let's actually give ourselves all of these. So we need to think about all of the different possibilities. You could have plus or minus 1 sitting on top of plus or minus 1. That's plus or minus 1. You could have plus or minus 1 sitting on top of plus or minus 4. That's plus or minus 1/4. Or you could have plus or minus 1 on top of plus or minus 2. That's plus or minus 1/2. And we'll keep doing this. All right, so 12 over 1 plus or minus 12. 12 over 4 is plus or minus 3. 12 over 2 is plus or minus 6. So now we're on to the 2. We have plus or minus 2. We have plus or minus 1/2 when the 2 is on top of the 4, but we've already considered that, so you don't need to count it again. And then you could have the 2 sitting on top of the 2, but that's plus or minus 1. We've already talked about it, so don't think about it again. Now you could have 6 on top of 1, but that's plus or minus 6. We've already talked about it. You could have 6 on top of 4. That's plus or minus 3/2. That's a new one. You could have the 6 on top of the 2, but that's plus or minus 3. We already have that one. And let's keep going. We could have 3 over 1. That's 3. We already got it. We could have 3 over 4. That's a new one. You could have 3 over 2. We already have that. You could have 4 over 1. That's a new one. You could have 4 over 4. We've already got 1. Or you could have 4 over 2. We already have 2. So these are the possible rational roots to this equation. Now, to actually see if they're roots, you would have to take all of these, plug them into this, and see if you actually get zeros.